Hey, 6th grade, today we are computing with scientific notation. First, let's do a quick review. Let's see, this is hundreds, thousands, millions, billions. This is 6,860,000,000. You want to write that as in scientific notation. So that's going to be 6.86 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. Now there's a sample problem in your book that compares that to 3 times 10 to the 8th. And it wants to know how many times greater is the world population than the United States population. So let's see if I remember correctly. How many times greater? That's a division problem. So I'm going to put the bigger one on top. That would be 6.86 times 10 to the 9th and 3 times 10 to the 8th on the bottom. So computing, this now works the same as anything else. Just have to look at the things that are the same, and then you can divide them. So 6.86, if I put that into my calculator, divided by 3, I'm going to get 2.286667. So it's basically 2.3 if I round it off, instead of 2.286666666, and on and on and on. Now if I have a 9 up here and an 8 down here, let's see, I think I can subtract those since we're dividing. 9 minus 8 is 1 times 10 to the first, which would basically be 2.3 times 10. That must be 23. Must be the answer, because 2.3 times 10 to the first is 23. Now when you're multiplying two scientific notation numbers together, you use what we've already done. We have 7.2 times 10 to the third, 1.6 times 10 to the fourth. And so for the first part, you can just do 7.2 times 1.6. 7.2 times 1.6, 11.52. And then 10 to the third and 10 to the fourth, since we're multiplying exponents, I can add those together. That'll give me times 10 to the 7th. Now, looks like you're done, but you only want one number in front of the decimal. So I'm going to move this to right there. So that means it's not 11.52, it's 1.152. And the easy way for me to remember this is, since I have made this number over here smaller, I make this number over here bigger. So it's times 10 to the 8th. So I had two numbers in front of the decimal here. I only wanted one. So I moved the decimal, one spot to the left. I made the number smaller. Instead of 11.52, it's 1.152. And then, since I made that one smaller over here, I'm going to make this bigger, from 10 to the 7th, 10 to the 8th. Here's another division example. Again, since I have these numbers that are both numbers and these are the scientific notation, the exponents, I can keep them separate. So first I'm going to do 8.37 divided by 2.7, and I'm going to get 3.1 times 10 to the, alright, 8 minus 3 is 5. This only has one number in front of the decimal, so looks like we're done. Here's one more multiplication example. 9.75 times 10 to the third times 8.4 times 10 to the 6th. So I'm going to do 9.75 times 8.4 first. I have 81.9. Now, if I add these together, 10 to the third times 10 to the negative 6th, that would be 10 to the negative third. First, I need to move this over one spot because I want one number for scientific notation. So I'll make that 8.19. I made that number smaller, which means I need to make this number bigger. It's a negative 3 right now. To make it bigger, it becomes negative 2. Right? Negative 2 bigger than negative 3. Now, when you add or subtract, what you have to do is you have to get the exponent numbers to match. It's kind of like adding and subtracting fractions. You have to have the denominator the same. You have to have the exponent number the same, because that way you have all of your other numbers will line up. And I'll give you an example of that here. If I have 1,000 and 30,000, if I'm adding them together, I need to make sure that I have an answer of 31,000 and not an answer of 40,000. So this would be 1 times 10 to the third, and this would be 3 times 10 to the fourth. Now, the same stuff I've done already is the same thing I would do here. I either need to make the 3 into a 4 or the 4 into a 3. I'm just going to change this into 10 to the fourth. So if I do 10 to the fourth, I've made that number bigger, so I need to make the other number smaller by putting it like that, from 1 to 0.1. So again, a 3 to a 4 gets bigger. That means the decimal, which is right here, needs to go here to make that smaller. One gets bigger, the other gets smaller. Now I can add them together since they match. 3, whoops, forgot my marker. 3 plus 0.1, that'd be 3.1 times 10 to the fourth, which, let's see, 3 and then 4 spots, 1, 2, 3, 4. And that is the answer we should get. Now looking at the one we started with, 8.9 times 10 to the ninth, 4.2 times 10 to the sixth. It really doesn't matter which way you do it, you're going to get the right answer either way. So I might make this, let's see, well this one would have to go down 3, this would have to go up 3. Well, I might make this one go down 3. So 10 to the 6th. That got smaller by 3 spots. So that means the other number has to get bigger by 3 spots. 8.9. So if I did that, it'd be 1, 2, 3. So it was here, and I'm moving it 1, 2, 3. So that should be 8,900 times 10 to the 6th plus 4.2 times 10 to the 6th. And now I should get 8904.2 times 10 to the 6th. Alright, now same thing again. I need to move this 1, 2, 3. So I'm going to make this 8.9042. I made this one 3 spots smaller, which, maybe no surprise, should make this one 3 bigger. So the answer we should get for this one should be 8.9042 times 10 to the 9th. Alright, now this one is subtraction one, and you have to do another thing here where you have to actually turn them both into scientific notation. So first, let's see, that would be 1.17, and then let's see, 1, 2, 3, 4, 5. Alright, times 10 to the 5th. Well, I'm subtracting from 10 to the 6th, so maybe what I'll do is make this 10 to the 6th, make that bigger, so then this gets smaller by 1 spot. So 5 goes up to 6 and gets bigger, so 1.17 becomes 0.117 and gets smaller. Now I can do 1.35, since everything matches. I can do 1.35 minus 0.117. 1.35 minus 1.17. No, 1.35 minus 0.117. That will give me 1.233 times 10 to the 6th. And that should be the answer because I only have one number in front of the decimal. So, I think I can tell you an assignment now. So we have pages 63 to 65, numbers 1 through 14, and 19 to 24. It's about 20 problems. That shouldn't be too bad. See what you can do. See how it goes.